Hi everyone, we're here in Foundations of Mathematics and I have a topic which is the coding theory. I am lovely Rachel's ESTRERA, by the way. So coding theory. Coding theory is the study of the properties of coders and their respective fitness for applications. It is also the branch of mathematics dealing with the art of transmitting messages reliably over a noisy channel by adding or removing redundancy to the message. There are three areas associated to coding. First, we have the data compression. This is concerning with efficient encoding of source information so that it takes a little space as possible. It is also possible by removing redundancy from the data. So we have here the formula in getting the percentage of the efficiency of codes. We have eta is equivalent to h of x over e of l. Here are the steps on how to get a percentage of efficiency of the 6 alphabet symbols such as A, B, C, D, E, and F, where the codes can be located in the third column. So the code of A is 00, the code of B is 01, so on and so forth until it reaches up to the last row. We have the F code is 111. So the probability of occurring of A is 0.30, B is 0.25, so on and so forth. So the code entropy is equivalent to summation of negative p of x of I times logarithm base of p of x of I, where I is equivalent to 1 from 1 to n. And let's examine here the table. So we have the first column, the symbols A up to F, then their probability. The logarithm base 2 of p of x of I can be obtained through using computer. So logarithm base 2 of 0.30 is negative 1.74. And how to get the negative p of x of I logarithm base 2 of p of x of I? So we have to multiply only the p of x of I and the logarithm base 2 of p of x of I. So 0.30 times negative 1.74 is 0.52. So on and so forth until it reaches up to the last row, which obtains 0.22. So when we add these values in the fourth column, we came up with a 2.36 bits. So here is the average code length. The average code length can be obtained through getting the summation of p of x of I multiplied by the code length L sub I from I is equal to 1 up to I is equal to n. So p of x of I is the probability of symbol, while L sub I is the code word length. So since we have here the first, second, and the third columns, we have familiarized already that one. We have to proceed to code length. How to get that? So since A has a code of 00 and there are two codes, that is a code length. And B 01, the code length is 2. So on and so forth until F. F has a code of 1111 and the code length is 4. So when we multiply the code length by the probability, we get 0.60. Then 0.25 multiplied by 2, that becomes 0.50, so on and so forth. And we get the sum of the fifth column, 2.38 bits. Since we get already the entropy code and the code length, the average code length, now we have to proceed to dividing those values. So 2.36 over 2.38, that becomes 0.9915. And when we multiply it by 100%, we get 99.15%. Thus, it is the efficiency of the codes in data compression. Next, we have the second, error correcting codes. This is concerning with improving reliability of communication over noisy channels, and it is achieved by adding redundancy. Let's consider the Hamming weight. So we have this symbol. W, then the dot, it is the number of non-zero digits in the code word, the number of ones. So let's consider here the Hamming weight of 00110 is equivalent to 2. Why? Because we only have 2 number ones here. Then W of 111 is equivalent to 3 because there are 3 number ones here, so on and so forth. While the Hamming distance is the number of digits where 2 code words differ. So we have the 2 or the couple of codes here. We have 000, then 111. We have to compare each codes from position right up to the left. So 0 and 1 are different, so on and so forth. So since we have 3 difference here, so that is considered as Hamming distance. So D, as we all know, that it stands for distance. And how to get a number of errors detected. So we have to subtract the distance by 1. And when we simplify or when we get the number of errors corrected, we have to consider this D minus 1 over 2. So example, best 3 of 5. We have 5 number ones here. So the distance is 5. And the number of errors detected is 4. And the number of errors corrected is 2. So let's examine this example. Messages 10000010 and the sum is 1010, as well as the valid code words. Thus, 2 valid code words when added will result to valid code words also. So here, let's proceed to the number 3, which is the cryptography or the cryptology. This is concerning with security, privacy, or confidentiality of communication over a non-secured channel. Example, the words I love you will be encrypted to something add words. So these are the alphabet letters, and we have 26 alphabet letters, the English alphabet. So since the positional number of I is 9, so we have to consider this. It's 9. And the words I love you here will be added by the keyword computer as the constant key. So 9 plus 3 is 12. The 12th letter is L. So the first letter is L. Then the positional number of L here is 12. So when added by the positional number of O, which is 15, so that becomes 27. Since the alphabet letter is just only 26, we have to start again from the very beginning. That is from A. So 26 when added by 1, that's 27. So the first positional number is also 27. That is A. Until the last letter. So we obtained LABLZSTM, the lab LZSTM. How to decrypt? In order to find the meaning, we have to subtract this encrypted word or encrypted letters by the keyword computer. So 12 minus 3 is 9, and the 9th letter is I. 27 minus 15, that is equivalent to 12, so the 12th letter is L. How about this one? 12 minus 16, that becomes negative 4, right? But we have no negative in the English alphabet as positional number. So we have to add 12 by 26, since 26 is the number of alphabet letters. So 12 plus 26 is 38, subtracted by 16 is a positional number of P. So 38 minus 16, that becomes 22, so on and so forth. Until we obtained the words I love you. So crypto system, as we all know, that when sending messages, it's not really the message that we have typed that the receiver can receive. It's actually the codes, because computer only accepted binary codes, 2 numbers, we have 0 and 1. So from sender, that is encrypted as the process, and then it will be decrypted by the computer, then it will be received by the receiver. So let's be careful, because even though it has an encryption, the hackers can also hack that. So we have to be careful in considering the security number or the password, because it might be hacked by the hackers. And hackers, we all know that they are really techy. So that's it. And that's my report all about. Again, I am lovely Rachel ESTRERA reporting. Goodbye.